Hello, my cherished viewers. You are welcome to today's class. Today, we are going to look at the WASSCE 2025, the elective math they wrote, the solution to the questions that dropped when they sat for the examination. So sit comfortably wherever you find yourself, pick a calculator, get your notebooks or exercise books, pen, pencils, so that as the question comes, we can all learn them together. So viewers, let's start with the question. WASSCE 2025. Solutions to WASSCE 2025. Elective mathematics. Now we all know that WASSCE is West African Senior School Certificate Examination. This particular examination is prepared by WAEC, that is West African Examination Council. So they give to some of the West African schools and they prepare them for the tertiary institution. So with the elective math that they sat for 2025, we are here to look at the solution to the questions. Now, they were supposed to answer 12 questions in all, 8 compulsory questions, then they select 4 from the optional part. So in this video, we are going to look at some of the questions. Let's start with the question 1. Question 1. A binary operation circle plus is defined on the set of real numbers R by P circle plus Q is equal to PQ over 7 plus P plus Q, comma, where P, Q belongs to real numbers. First up, find the A inverse of -2 under circle plus. B, truth set of M circle plus 5, which is equal to M circle plus 7. And this is the question for the number 1. So let's look at the solution. A. So if you look at the question we have here, you have been given a binary operation. P circle plus Q, and the definition is PQ over 7 plus P plus Q. So anytime a binary operation is given to you and you are asked to find for the inverse, you need to get your identity element first. So let E be the identity element. So from here, P circle dot E is always equal to the variable. So P circle dot E is always equal to P. By comparison, by comparison, by comparison, P is P, but when you look at here, Q is now E from here. So anywhere I see Q, I am going to substitute E over there. So from the definition, it's going to be PE over 7 plus P plus Q. But now I have E here, which is equal to P. So from here, I am going to group like terms. So I have PE over 7 plus E is equal to P. Then when this P goes there, we have minus P. So now we are going to get PE over 7 plus E is equal to 0. So from here, we are going to multiply each side by 7. So we have 7 times PE over 7 plus 7E is equal to 0 times 7. So now this can take off this. So it will left with PE plus 7E is equal to, we all know that 0 times 7, we still have 0. Then when we get here, we are going to factor E out. So we have E into bracket P plus 7 is equal to 0. We need to make E the subject. So I'll divide here by P plus 7 and divide here by P plus 7. So this will take off this, then we have the identity element to be 0. So this will be the identity element. Since we have the identity element, we can now get the inverse. For inverse, P second plus P inverse is always equal to the identity element. P second plus the inverse of P is always equal to the identity element. This is why before you can find the inverse, you have to get your identity element first. So by comparison from the main definition, anywhere I see Q, I am going to substitute P inverse there. So from the definition, we have PQ here. So here is going to be P inverse because we are multiplying P and Q. So from here, we are going to multiply P and P inverse over 7 plus what we have here is P. So I'll still repeat the P plus P inverse because as I said earlier, anywhere I see Q, I'm going to put P inverse there. It's equal to the identity element, which is 0 from what we had here. So from here, we are still going to group like terms. So we have P inverse over 7 plus P inverse. Now when I bring this P to the other side, it becomes negative. So we are going to have 7 times P inverse over 7 plus 7 times P inverse is equal to 7 times minus P. So we are going to dissolve the denominator. In that case, we have to multiply each term by 7. So this will take up this. Then we are going to get P inverse from here plus 7P inverse is equal to negative 7P. So this take off that, we have P inverse. 7 times P inverse, we have 7P inverse. 7 times negative P, we have minus 7P. So from here, we are going to factor P inverse out. So we have P inverse into bracket. P plus 7 is equal to minus 7P. Then I'll divide here by 7 plus, I'll divide here by P plus 7, and I will also divide this side by P plus 7. This can take up this. So I have P inverse to be equal to minus 7P all over P plus 7. But the main question was to find the inverse of negative 2 under circle plus. Inverse of negative 2. If we are looking for the inverse of negative 2, then from the expression we have here, we are going to substitute the negative 2 at where we see P. So we are going to get minus 7 multiply negative 2 all over. So I just substituted negative 2 at where I have P. And here we are going to get negative 2 plus 7. So from here, negative 2 times negative 7 times negative 2, we have positive 14 over negative 2 plus 7, we have 5. And we can rewrite this one a mixed fraction. So we are going to get 2 whole number 4 over 5 to be the final answer for the A. So now let's look at the B part of the question. B, the truth set of m circle plus 5 is equal to m circle plus 7. So this is the B part of the question. By direct comparison, this is P, this is Q. So if you look at the definition on top here, they multiplied P and Q. So over here, we are also going to multiply M and 5. So we have 5M over 7. Because after multiplying, they divided it by 7 from the definition. Plus, the next item is P. But here now P is M. So plus M. Plus Q from here. So here plus 5. Which is equal to, we are going to deal with this one in the same way. So this is my new P, this is my new Q. So here we are also going to multiply. So M times 7, we have 7M over 7 plus P. From here my P is M. So plus M plus Q, which is also 7. So from here, this can take off this. We can cancel out the 7. Then we are going to get 5M over 7 plus M plus 5 is equal to m plus m, we have 2m plus 7. Because of the denominator, we need to multiply each term by 7. So we have 7 times 5m over 7 plus 7 times m plus 7 times 5 is equal to 7 times 2m plus 7 times 7. So when you get here, we are going to simplify. 7 will take off 7. We have 5m plus 7 times m. We are going to get 7m plus 7 times 5. We have 35 is equal to 7 times 2m. We have 14m plus 7 times 7. We have 49. So from here, we are going to continue with the simplification. 5m plus 7m, we have 12m plus 35 is equal to, then we continue with the rest, which is 14m plus 49. So now we are going to move on. So from here, we need to group like terms. We have 12m. Then when 14 move to the other side, it becomes negative 14m is equal to, after the equal to, what is left here is 49. Then when 35 also move to the other side, we have negative 35. If that's the case, 12m minus 14m, we have negative 2m is equal to, and from here 49 minus 35, we are going to get 14. So I'm going to divide here by negative 2, here by negative 2. This will take off this, and m is equal to negative 7. But the question said the truth set. The truth set. So you need to conclude. Therefore, the truth set is, then you have to indicate your curly bracket. M is such that m is equal to negative 7. So my cherished viewers, this will be the final answer for the B part. If you find this video to be very, very educative and helpful, don't forget to like this video, subscribe if you haven't subscribed yet, share to anybody writing WASSCE, anybody who is in SHS, and I believe it will help such a person. Let's look at the question 2 of WASSCE Elective Maths 2025. Question 2. If alpha and beta are the root of an equation such that alpha squared plus beta squared is equal to 21, and alpha plus beta is equal to negative 3, comma, find the equation whose roots are alpha over beta minus 2 and beta over alpha minus 2. So this was the compulsory question 2. So let's get how we are going to deal with this question quickly. Now over here, the question is saying that find the equation. Find the equation. And we have a general form for finding equation where roots are given. So generally, the equation is given by x squared minus sum of the roots x plus product of the roots, which is equal to 0. So this is the general form for finding equation when roots are given. Now we have alpha squared plus beta squared. It has been given. Alpha squared plus beta squared is equal to 21. Then we have alpha plus beta is also equal to negative 3. But something is missing here. What is missing here is alpha beta. That's the product of alpha and beta. But we can get the alpha beta from the first one because alpha squared plus beta squared, its expansion is alpha plus beta all squared minus 2 alpha beta. So this is the expansion. Now from here, this alpha squared plus beta squared has been given to be 21. So we have 21 is equal to alpha plus beta, we have negative 3 squared minus 2 alpha beta. So from here, the alpha beta was not given in the main question, and there is a need for us to find it. So we still have 21 is equal to negative 3 all squared. We have 9 minus 2 alpha beta. When you get here, we are going to group like terms. So we have 21 minus 9 is equal to negative 2 alpha beta. 21 minus 9, we are going to get 12 is equal to negative 2 alpha beta. So from here, we need to divide through by the negative 2. So here over negative 2, here over negative 2. This can take out this. So I have alpha beta to be equal to negative 6. And this will be the answer for the alpha beta. So now, we are now going to find the sum of the roots as well as the product of the roots. Then we can make substitution here. So now let's start. Sum of the roots. So sum of this root, which is alpha over beta minus 2 plus beta over alpha minus 2. When you want to get the sum, then we have to find the LCM. So from here, the LCM is going to be beta minus 2 multiplying alpha minus 2. Beta minus 2 and alpha minus 2, the product. This is the same as this. In that case, the alpha minus 2 will be multiplying the alpha from the numerator. So we have alpha multiplying alpha minus 2 plus beta also multiplying. This is also the same as this. So in that case, this will multiply the beta. So we have beta multiplying beta minus 2. So now from here, let's expand. Alpha times alpha, we have alpha squared. Alpha times negative 2, we have minus 2 alpha. Beta times beta, we have beta squared. Beta times negative 2, we are going to get negative 2 beta minus 2 beta. All over, we have to also expand the denominator. Beta times alpha, we have alpha beta. The same beta here times negative 2, we have minus 2 beta. Negative 2 times alpha, we have minus 2 alpha. Then negative 2 then negative 2 times negative 2, we have positive 4. So if that's the case, then we can simplify it then. So we have alpha squared from here plus beta squared from here. Then we have minus 2 alpha minus 2 beta. So alpha squared here, beta squared here, minus 2 alpha minus 2 beta. All over alpha beta. Then here we are going to rearrange. So it is going to be minus 2 alpha. So I'm writing the minus 2 alpha first before the minus 2 beta plus 4. Then from here we have alpha squared plus beta squared. Then negative 2, they are common in both terms. So we can factor negative 2 out. So we have minus 2 into bracket alpha plus beta all over alpha beta. Then here we can also factor negative 2 out. So you have minus 2 into bracket alpha plus beta. Then we are going to add the plus 4. So we are going to continue from this side. So from here, we are going to make substitution. Alpha squared plus beta squared, everything here, we are going to represent the 21 because it was given to us in the question. So we have 21 minus 2 multiplying alpha plus beta. From here, we had negative 3. Negative 3. All over alpha beta, we were able to get negative 6. So we have minus 6 minus 2 minus 2 from here. Alpha plus beta, we still have negative 3. So we have minus 3 plus 4 plus 4. So from here we have 21 plus 6 because negative 2 times negative 3, we have positive 6 all over neg 6. Then neg 2 times neg 3, we also have positive 6 plus 4. Then we know that 21 plus 6 we have 27 all over negative 6 plus 6, it will give us 0. So I have cancelled it out, all over 4. And this will be the sum of the roots. So we are here to get product of the roots. Product of the roots. All right. Now we know that the roots were alpha over beta minus 2 multiplying beta over alpha minus 2. So these are the roots, and you want to find the product. Here we have two fractions, and when two fractions are multiplying, we are going to multiply the numerators. So alpha times beta, we have alpha beta all over. Then we need to also multiply the denominators. So beta times alpha, we have alpha beta. This same beta times negative 2, we have minus 2 beta. Then now, negative 2 times alpha, we have minus 2 alpha. Then, negative 2 times negative 2, we have positive 4. So we have alpha beta all over another alpha beta. Then from here, we can try to rearrange to get minus 2 alpha, which is here, then minus 2 beta, which is also here, plus 4. So we have alpha beta all over the same alpha beta was that. Then we could see that there is negative 2, another negative 2. So we can factor negative 2 out. So we have minus 2 into bracket alpha plus beta plus 4. So from here, we are going to make substitution. Alpha beta, we had negative 6. All right. So from here, we have alpha beta to be negative 6 all over. Here, we also have another alpha beta, which is negative 6 minus 2 multiplying alpha plus beta, we know that it is negative 3. So negative 3 plus 4. We have plus 4 here. Then we still have negative 6 to be the numerator. Then another negative 6 plus 6, because negative 2 times negative 3, we have positive 6 plus 4. So from here, this we also take off this. Then we have next 6 over 4. And when we simplify this in its lowest form, we are going to get negative 3 over 2 to be the product of the root. So now we can now get the equation. Generally, as we did, it was x squared minus the sum. And with the sum, this is the answer we had. So minus 27 over 4x plus the product. And this is the answer we have for the product. Negative 3 over 2 is equal to 0. Because we have denominators, or we have fractions here, they are going to multiply each by the LCM. So from here, the LCM is 4. So we have 4 times x squared minus 4 times 27 over 4x minus 4 times 3 over 2 is equal to 4 times 0. So you're multiplying through by 4. So from here we have 4x squared. This can take up this minus 27x. 2 goes here 1, 2 goes here 2. So we have minus 6 is equal to 4 times 0. We still have 0. So the equation is going to be 4x squared minus 27 minus 6 is equal to 0. And this will be the final answer for the question 2. Let's look at the question 3. Under the compulsory part, WASSCE elective math 2025. Question 3. Given that n plus 1 combination 4 minus n minus 1 combination 4 plus 6 is equal to 4n, comma, find the value of n. Find the value of n. All right. Generally, with combinations, generally, n combination r, let's look at its definition. The definition is always n factorial all over n minus r factorial multiplying r factorial. So this is the general part when it comes to combination. So from here, we are going to get n plus 1 factorial all over n plus 1 minus 4, n plus 1 minus 4 factorial, then 4 factorial, just like the general form. Minus, over here we also have n minus 1 factorial all over n minus 1 minus 4 factorial, n minus 1 minus 4 factorial, then the 4 factorial, which is equal to 4n. Then when I bring the 6 here, it is going to be negative 6. So in here, we are still going to simplify them. So we still have n plus 1 factorial all over n. 1 minus 4, we are going to get negative 3 factorial, then 4 factorial, minus n minus 1 factorial all over n. And we have negative 1 minus 4. We are getting negative 5 factorial, 4 factorial is equal to 4n minus 6. So now we are moving on. If you are asked to find 7 factorial, let's look at the expansion. With 7 factorial, we start from the 7, multiplying difference 1 of the 7, giving you 6. Multiplying difference 1 of the 6, giving you 5. Multiplying difference 1 of the 5, giving you 4. Multiplying difference 1 of the 4, giving you 3. Multiplying difference 1 of the 3, we have 2. Difference 1 of the 2, we have 1. And this is how factorial is written. So over here, if I want n plus 1 factorial, then first of all, I will start from n plus 1. Then difference 1 in that order. So here, I will start from n plus 1. This will be my first term. Then n plus 1 minus 1, I'll get n. Then this n minus 1, I have n minus 1. N minus 1 minus 1 again, I have n minus 2. N minus 2 minus 1, I have n minus 3. And I'll end here, factorial. The reason why I am ending here is because I have a denominator with n minus 3 factorial so that they can cancel out. So all over n minus 3 factorial 4 factorial minus, the same thing applies to this. So here, with this factorial, I'll first of all write the n minus 1 first. So I have n minus 1. So from here, n minus 1 minus 1, we have n minus 2. N minus 2 minus 1, we have n minus 3. N minus 3 minus 1, n minus 4. N minus 4 minus 1, I have n minus 5. And over here, I am also going to end on n minus 5 factorial because the denominator has n minus 5 factorial. So all over n minus 5 factorial 4 factorial, which is equal to 4n minus 6. So from here, let's do the cancellation. This can't cancel this. And again, this can cancel this. So now let's look at what we are going to get next. So we have n plus 1, n minus 1, n minus 2, all over 4 factorial. And we know that 4 factorial is, you can use the calculator to help me. What did you get for 4 factorial? We have 24. Very good. So we have 24 minus, and from here we have n minus 1, n minus 2, n minus 3, n minus 4, all over 4 factorial again, which is also 24. And it is equal to 4n minus 6. 4n minus 6. So now let's look at how we are going to continue from here. From here, we have n minus 1, we have n minus 2. And from here, we also have n minus 1, n minus 2. So for it to be very easy, we are going to factor n minus 1, n minus 2 out. So we have n minus 1, n minus 2. Then they all have common denominators. So all over 24. In a big bracket, n minus 1 is already here, n minus 2 is already here. So it will left with n plus 1 and then n minus. When I get here, n minus 1 is here, n minus 2 is also here. It is also left with n minus 3 and n minus 4, which is equal to 4n minus 6. So when we get here, we need to expand this as well as this. So now I'm going to start with expansion here. N times n, I have n squared. N times minus 2, I have minus 2n. Negative 1 times n, I have minus n. Negative 1 times negative 2, I have positive 2. All over 24 in a big bracket. So this and this, I am also going to multiply. N times n, I have n squared. Then 1 times n, I have n minus, bracket open. I need to expand this to n times n, I have n squared. N times negative 4, I have negative 4n. Negative 3 times n, I have negative 3n. Negative 3 times negative 4, I have positive 12, which is equal to 4n minus 6. So from here, we are going to simplify them once again. So from here, this n squared, I'm going to repeat it. So we have n squared. Negative 2n minus n, we have minus 3n plus 2 all over the denominator, we have 24. Multiplying, here we have n squared plus n minus, bracket open. What start here is n squared. Then minus 4n minus 3n, we are going to get minus 7n plus 12, which is also equal to 4n minus 6. We are moving on. So we have n squared minus 3n plus 2 all over 24 in a big bracket. So from here, the negative will affect everything from the bracket. So we are getting n squared plus n. Then negative will affect this. We have minus n squared. Negative, negative, we have positive 7n. Negative by 12, we have minus 12, which is equal to 4n minus 6. So we are going to simplify what we have here. This can take out this, because this is positive n squared, we have minus n squared. They will move 0. So we have n squared minus 3n plus 2 all over 24, and now they are multiplying. So from here, n plus 7n, we have 8n minus 12, which is equal to 4n minus 6. So when it gets here, we can factor 4 out, and here we can also factor 2 out. So we are going to do factorization from here. So we have n squared minus 3n plus 2 all over 24 in a big bracket. We know that we can factor 4 from here. So we have 4 into bracket 2n minus 4. So we have 3. So you could see that 4 times 2n, we are still getting 8n. 4 times negative 3, we have minus 12. Factorization, which is equal to, then from here we can also factor 2 out. So we have 2 into bracket 2n minus 3. So over here we could also see that 2 multiplying 2n, we have 4n minus 2 times 3, we have 6. From here, this 4 can reduce the 24 by 6 because 4 goes into 24 6 times. So now we have n squared minus 3n plus 2 all over 6 multiplying 2n minus 3 is equal to 2 into bracket 2n minus 3. From here we could see that there is 2n minus 3, another 2n minus 3, and we have an equal to here. This means we can divide here by 2n minus 3 and also divide here by 2n minus 3, so that this can take off this can also take off this. It will cancel out. Then it will be left with n squared minus 3n plus 2 over 6 is equal to 2 over 1. So from here we are going to cross multiply. 6 is multiplying the 2, then the quadratic is also multiplying the 1. Everything here times 1, we still have n squared minus 3n plus 2. Everything times 1, we have the same thing. Then 6 times 2, we have 12. So here, the 12 will move to the other side. So we have n squared minus 3n plus 2 minus 12 is equal to 0. So we have n squared minus 3n minus 10 is equal to 0. So now let's look at the factors. The factors are going to be, so the factors are n plus 2 and then n minus 5, which is equal to 0. So now we are going to get n plus 2 is equal to 0, where n is equal to negative 2. Then we have n minus 5 is equal to 0, where we have n is equal to 5. But here, since n is not negative, therefore n is equal to positive 5. With combination does not take negative figures. So when you put negative 2 here, you are going to get negative 3 combination 4, which is going to be math error. Question 4. Resolve 2x cubed 2x squared plus 7x plus 33 all over x cubed plus x squared minus 11x into partial fractions. So when you're asked to express or resolve a function like this in partial fraction, this is how we are going to do it. So we have 2x squared plus 7x plus 33 all over. Then you could see that there is x here, x, so we can factor x out. So we have x into bracket, it will be left with x squared plus x minus 11. So this will be the new function, which is equivalent to a over x, a over the denominator here, plus, we could see that this is quadratic, and when it is quadratic, the numerator is going to be a linear, which is bx plus c all over x squared plus x minus 11. So from here, we still have 2x squared plus 7x plus 33 all over x into bracket x squared plus x minus 11 is still equivalent to, then from here we can find the LCM. So LCM of this and this, we have x into bracket x squared plus x minus 11. This will be the LCM, just like the denominator we have from here. This is the same as this. In that case, the other one will multiply the a. So we have a multiplying x squared plus x minus 11 plus bx plus c will also multiply. We could see that this is also the same as this, so to multiply the x we have here. So it will multiply x, Now from here, the denominators are the same, so we can equate the numerators. So we are going to get 2x squared plus 7x plus 33, which is equal to a multiplying x squared plus x minus 11 plus bx plus c also multiplying x. All right. So here we are going to find the value of x that can help us to get one of the variables, whether a, b, or c. So the value of x we are going to use is when x is equal to 0. We could see that when I put 0 here, the 0 will multiply everything and b and c will be eliminated. And again, when I put 0 here and I put 0 here, I can easily get the value of a after making substitution. So we have 2 into bracket 0 squared plus 7 multiplying 0 plus 33 is equal to A into bracket 0 squared plus, we could see that there is x and the value of x is now 0. So 0 minus 11 plus b multiplying 0 because the value of x is 0 plus c, everything still multiplying 0 because of the x. If that is the case, 0 squared, we still have 0 times 2. We have 0 plus 7 times 0, we still have 0 plus 33 is equal to a multiplying 0 squared is 0 plus 0, we still have 0. 0 minus 11, we have negative 11 plus everything here we move 0 because 0 times anything is still 0. Alright, so from here we have 33 is equal to negative 11a. Then I'll divide through by the minus 11. So this will cancel this. I have a to be equal to negative 3 to be the value of a. Before we can get the value of b and c, then we need to expand this so that we can compare the coefficients. So let's move on. So we have 2x squared plus 7x plus 33 is equal to, so I will take this a and use it to multiply everything we have from the bracket. So a times x squared, I have x squared. A times x, I have ax. A multiplying negative 11, I have minus 11a plus bx times x, I have bx squared. C times x, I have cx. When you get here, we need to group like terms. So I have 2x squared plus 7x plus 33 is equal to, I have ax squared here. I also have bx squared. So they all come to one side. Ax squared plus bx squared. And again, we have ax, cx. They will also be grouped at one side. So plus ax plus cx. Then we have minus 11a from here. So minus 11a. When we get here, we have to sort them. We have to sort them. So we have 2x squared plus 7x plus 33 is equal to, all of them, they are all of x squared. So we can sort by writing a plus b or x squared. We've sorted them out. Then here we have a plus c all of x. Then this is the constant, which is negative 11a. Now we know the value of a, but from here this one will help us to get the value of b by comparing the coefficient of x squared. So let's move on from here. Comparing coefficient of x squared. So from here, the coefficient of x squared is 2. So we have 2, which is equal to, and from here, the coefficient we have here is a plus b. So it's equal to a plus b. So now we have 2 is equal to, now we know that the value of A is negative 3. So we have negative 3 plus B. Then we have 2 here. When negative 3 moves to the other side, we have positive 3 is equal to B. Then we have B is equal to positive 5. And this will be the value of B. So now let's look at the value of C, how we can do it. So here we are also comparing. So here we are going to compare the coefficient of x, because that is where the C can be found. So comparing coefficient of x, we could see that from here the coefficient of x is 7. So we have 7 is equal to, and the coefficient we have here is a plus c. A plus c. But we had the value of A to be negative 3. So we have negative 3 plus C. And here we can bring the negative 3 to the other side. We are going to get 7 plus 3 is equal to C. Then C is equal to 10. So now we can conclude and get the final answer. Now we all know that this was the question. So we can say that 2x squared plus 7x plus 33 all over x cubed plus x squared minus 11x is now equal to, now if you remember the breakdown, it was a over x plus bx plus c all over x squared plus x minus 11. This was the breakdown. So from here, we are only going to make substitution of the values of A, B, and C. So now we have our final answer to be 2x squared plus 7x plus 33 all over x cubed plus x squared minus 11x is equal to, we know the value of A to be negative 3. So we have negative 3 over x plus, the value of B is positive 5. So 5 times x, we have 5x plus C, which is 10 all over x squared plus x minus 11. And this will be the final answer for the question for WASSCE Elective Math 2025. Let's look at the question 5.